Hello guys, and welcome to another episode of biology. And of course today we're going to continue our study of ecology. Okay, but we're looking at what soil today. All right, I'm looking at what the soil. Okay, so we're going to see all about the soil, conservation, fertility, and so on and so forth in this episode. Now, do not forget that these tutorials, these episodes, they're all brought to you by the O3 Schools app. We have the JAMB app, we have the WAEC application. Now, WAEC is going CBT, so more than ever before, you need a good application like the O3 Schools app, okay? Download it from Play Store, download it from App Store, okay? And also download for your computer system. If you want to download, just message this number on WhatsApp, all right? You get the app operating, okay? Then, of course, before we begin, let us see a past question from the JAMB app. This is a 2015 question. 2015 number 30. Okay, it says here that the increasing order of the particle size in the following soil types is A says is silt to sand to clay then to gravel. B says it's clay to silt to sand to gravel. C says it is silt to clay to sand to gravel. This says it is clay to sand to silt to gravel. As easy as this may be, okay, if you do not know it, you do not know it. That is why at O3 Schools, we provide value for you first. Okay, let us teach you, and we believe that once we have taught you properly, answering questions will be the very least of your problem. That is why we encourage you to complement what these videos we do with the application. Download the application from Play Store, from App Store, for your computer system, all right, and start practicing your way to success. It has everything you need to succeed. The app has everything you need to succeed in your exam. All the past questions for all the subjects on the application, so you wouldn't even need to go and buy past questions. All right. Likewise, there's a question search feature, just like where we search for this question now. Just go into the app, click on question search, click on biology, the subject, then search for what? For soil. All the questions, anywhere that JAMB has ever set anything that looks like soil will come out for us to answer, thereby making us to build confidence after reading a particular topic. Again, we have what the classroom feature. The classroom feature is a bomb because it has the recent JAMB syllabus. Aside from that, it has lecture notes, okay, that are structured according to that syllabus. So you wouldn't even need to buy textbook. Those of you are saying, which textbook is recommended should I read for this one? You do not need to bother about that at all, okay? So in the classroom also, you can create a study plan. A study plan is like a timetable. So what the app does to you is that it will you select the subject you want to study. Okay, if it's 4 subjects for your JAMB or 7 or 9 for your WAEC, it will crash all the syllabus for all those subjects. Create a timetable for you so that you can easily finish the syllabus. Okay, so wonderful feature. Also, there's a mock challenge. Also for the JAMB app, there's the WAEC app, okay? Okay, we have challenge on both apps every Saturday. All right, so what you need to do is what? Come to the app on Saturday by 10 a.m. for the JAMB, by 1 a.m. by 1 p.m. for the WAEC, okay? Come and compete with other students who are writing JAMB and WAEC for this year, okay? So you compete with them, win amazing prizes. But the reason why we do that challenge is not because of the prizes, it's because it's so that you can be getting used to what JAMB past question, getting used to JAMB likely exam question, as well as familiarize yourself with how JAMB or WAEC set questions, okay? And at the end of every challenge, all right, your results will be released, all right? Thereby what's making you to track how prepared you are per time for the exam. Download the app, activate it. Activation is less than the price of rice and chicken in a good restaurant, okay? So once you download the app, click on activate. At the top, once you click on activate, you see where they wrote buy activation key. Click on that buy activation key, all right? Then of course, click on what? Buy transfer. You see the account number on the app. You see the correct amount, okay, for the activation, all right? So let us talk about what soil. All right, so soil is not something that is new to us. All right, soil is something we see every day. Soil is what we have been taught in our primary schools. Soil is what we were taught in our secondary schools. All right, you encounter the soil every day. All right, so what is the soil? So you see that soil is what is the topmost layer of the what of the earth's surface. Okay, so we'll define soil. We'll say soil is the topmost layer of the Earth's surface from which plants grow, and what? Obtain nutrients. Okay, so we say that soil is what is the topmost layer of what? Of the earth's surface, okay, from which what? Plants grow and what? And obtain what? Nutrient. That is what soil, the topmost layer of what? Of the earth's surface from which plants grow, as well as what now? Obtain what? Nutrients, okay? And in this soils, we can find what? Some things, okay? For example, we can find living organisms. In the soil, we find what? Living organisms. We also see what? Inorganic or what? Mineral matter. Okay, in the soil, we also see organic matter. Organic, organic matter. Okay, or the one we call what? Humus. Also, we see what? Air. We see what? Water. Okay, so all of these, all right, is what we find what in the soil. So it's the topmost layer of the earth surface from which plants grow and obtain nutrients. And in the soil, we find living organisms. Okay, we find what's inorganic or mineral matter. We see what organic matter. Okay, or what we call humus. Then we see what air. Or I will see what water. Okay, all of these that are found was in the soil. But something that's important for us to also talk about is how soil is formed. Okay, soil formation, soil formation. All right, how is what this what soil what formed? Okay, and we'll say that what that soil is what is formed from parent rocks. So I'm talking about soil formation now. Okay, and we'll say that soil is formed. It is formed or they are formed. Okay, formed. It is formed from parent rocks through a process that is called weathering. Okay, so soil formation. Say what soil is formed from what? From parent rocks. Okay, through a process that is called what? Weathering. All right, and weathering is not a new term to you. All right, this is not the first time you're hearing about weathering. Okay, so we said that weathering. What's the first of all? What is weathering? We said that weathering is a process of gradually breaking down rocks. Weathering is a process of what? Or the gradual breakdown of what? Of rocks. Of what? Gradually breaking down hard rocks into smaller particles. Okay, so that's what we call what weathering. So weathering is what? It's a process of what? Of breaking down hard rocks, okay, into what? Smaller what? Particles. Okay, and when these hard rocks are broken down, what it forms is what? Is this what? Soil. Okay, so weathering is a process of gradually breaking down hard rocks into smaller particles to form soil. Okay, so that is that about that. So weathering is the process of breaking down hard rocks gradually into smaller particles to form what? Soil. Now, the rate of soil formation depends on upon what? Two or major factors. Okay, number one is the nature of parent rock. Nature of what? Parent rock. Then number two, the type of what? Weathering process. The type of weathering process. All right, take note of that. Okay, so we say what that the rate of what? Soil formation, all right, depends on what? The nature of what? Of the parent rock. Okay, and also the type of what? Of weathering process. Now, although there are different types of what? Of parent rocks, okay, different types, okay, but three major forms what occur, okay, and those are nothing more than what? The igneous rock that you know, the sedimentary rock, and the metamorphic what? Rocks. Okay, so we have the igneous rock, igneous. Okay, we have what? The sedimentary. All right, then have the metamorphic what? Rocks. All right. So these are the three major forms, okay, that occur, despite us having different type of parent rocks. Now the igneous rocks, they are the ones that are hard to break down. Okay, they are very difficult to break down. Right, they form that's one used for granites. Okay, and basalt. They are rich in potassium minerals. Okay, they are rich in potassium minerals. The igneous rock, they are very, very hard to break down. All right, the sedimentary, okay, they are easier to break down than the igneous. Okay, they are easier to break down than the igneous. In fact, just say they are easier to break down. The metamorphic, they are formed from either from volcanic eruptions or from sedimentary rocks. All right, so let us quickly just see the igneous rock. So the igneous rock, they are hard volcanic rocks. Igneous rocks are hard volcanic rocks that are formed when molten from a volcano or crack from a volcano or crack from a volcano or crack in the Earth's crust. Okay, in the Earth's crust pours out over the land. Pours out over the land. All right. So igneous rocks, they are hard volcanic rocks, okay, that are formed when molten from volcano, okay, or crack in the earth pours out over land. Okay, so those are igneous. Like I said, they are very very, very hard to break down. They are difficult. They are hard to break down. Right? They are the ones that give rise to granite. Okay, the ones that give out to basalt, okay, which are very rich in, like I said, potassium minerals. Please take note of that. Okay, so igneous rock, they are difficult to break down. Okay, they are difficult to break down. Sedimentary rock, they are easy to break down because they are formed as a result of compartment of sand, and dust or particles. Okay, so they are easy to break down. So let's quickly see sedimentary rocks. Sedimentary rocks, on the other hand, they are formed as a result. Sedimentary rocks are formed as a result of deposition of particles like sand, like mud, like sand and mud, by running waters in water bodies. Okay, so those are sedimentary rocks. Okay, they are rocks that are formed as a result of deposition of particles like sand, like mud. Okay, by running water in water bodies. So over a period of time, the sediment become compressed. Okay, they become compressed. Okay, by movement, all right, and then they become compacted over time. That is how the sedimentary rocks are formed. Now, sediment rocks or sedimentary rocks, they are easy to break down. Okay, like I said before, and they form sandstones. Okay, they also form limestones. Okay, this one, they are very rich. They are rich in in calcium. Please take note of that. Okay, so those are sedimentary rocks. They are formed as a result of deposition of particles like sand, like mud, by running water in water bodies. Okay, so now let us look at the third one, which is the metamorphic rock. Okay. Now, these metamorphic rocks, okay, they are formed by They are formed from From either volcanic rocks, all right, from igneous rocks or from sedimentary rocks, okay, that have overgone what we call changes in formation beneath the Earth's surface, either by intense heat or pressure. Okay, that is what forms what this what metamorphic what rocks. Okay, so they are formed are rocks formed from volcanic rocks, or what's the sedimentary rocks which has what undergone what we call changes in formation, okay, beneath the earth surface, beneath the earth surface, okay, either by what? By intense heat, either by what? By intense heat or what? Pressure. Okay, so this is what brings about what metamorphic rocks. All right, there are rocks formed from volcanic rocks or sedimentary rocks which have undergo changes in formation beneath the earth surface either by intense heat or pressure. Here in metamorphic rocks, the rocks become squeezed, they become stretched, okay, so that they can now become what? Flattened. Okay, so this is what happens in the formation of metamorphic rocks. Okay, so metamorphic rocks are rocks formed from volcanic rocks or sedimentary rocks which have what undergone changing in formation rather beneath the earth surface. Okay, either by intense heat or pressure, right? And the rocks here become squeezed. Okay, they become stretched so that they can be what? Flattened. Now, these are what the three major types of what igneous rocks that are formed. Now, let us now quickly talk about what weathering. Okay, the types of what weathering that we have. All right, so we'll now what continue with our study. But before then, we have what's it called? We have noticed that a lot of you do not support what we are doing here. You do not like our videos. You do not share. I've heard that some people have gone to juju to swear that their family they will never like. They'll never like the video, okay? They will not support, they will not share, all right? They even want your other fellow people that are writing exam to fail. Please, it is something very wrong. If you have not liked this video, that thing you are doing is very, very wrong. Click on the like button so that this video will be suggested to students who are preparing for exam like you. All right. So by simply liking the video, somebody will succeed because of you. All right. Many people message us and say, they are not aware that we are doing tutorials like this or lessons like this. Wow, that they have missed a lot, okay? That they will have scored more if they discovered earlier. So please do not be the reason why someone is failing. Okay, then also do not forget to subscribe to this channel. If you're a newcomer to this channel, click on the subscribe button, all right, and so that you'll be receiving notification whenever we release a new video. Then what more? Please ensure what copy the link of the video, copy it and share it to your class group, share it to your friends, share it to your loved ones. Let everyone come and study and succeed. That is the reason why we have the channel, okay, so that you can pass your exam at once. Okay, so let us look at what the types of weathering. Types of weathering. Now we have three types of weathering. Number one, we have that we call the physical weathering. We have that we call the chemical. Okay, then we have that we call the biological weathering. Okay, so these are the three types of weathering that we have. All right, so physical, chemical, and then biological weathering. Okay, so now what is physical weathering? So number one, we'll have physical weathering. Okay, so this physical weathering involves the action of heat, of frost, of water, okay, which now leads toward the eventual breakdown of the rock. Okay, so physical weathering involves, take note, involves the action of heat, okay, involves the action of frost, involve the action of water on the parent rock, okay, which eventually leads to the breakdown of the rock, okay. So involve the action of heat, frost, and water on the parent rock, which eventually leads to the breakdown of the rock. All right. So that is what physical weathering. The action of heat, frost, water on the parent rock, which eventually leads to the breakdown of what on the rock. Now, what about chemical weathering? So for chemical weathering, will be action of what of chemicals, okay, like acids, okay, which now eventually also lead to what to the breakdown of what of the rock. So for number 2, chemical weathering. This one what will be due to what now? Due to the actions of chemicals such as acids, which now what? Which weakens the rocks and eventually lead to their what? To their breakdown. Okay, so that is what now chemical weathering. They also have what the biological. Okay, this one involves what the what's the action of what of organisms. Okay, like plant roots. All right, so which also eventually will lead to the what to the breakdown of what of the what of the rock. So biological weathering. Okay, so this one is what due to the action of organisms on the rocks. For example, what plant what root, okay? So as plant root grows, okay, it can what? It can grow what? The root can become what? Very stronger and thicker, and then we can what? Enter into the rocks and what? And start what? Cracking them. Also, animals will dig and burrow into the ground, okay? And also this one can also what? Lead to what? To the what? To the breakdown of what? Of rocks, all right? So this is what weathering, the gradual breakdown of what? Of rocks, all right? To form what? Soil, all right? That is what weathering. These are the 3 types of weathering: the physical weathering, the chemical weathering, and what? The biological weathering. All right. And so this will now take us to the importance or functions of soil components. All right. All right. To talk about some soil components, talk about air, talk about water, talk about what organic water and inorganic matter. All right. So let us quickly see the importance or functions, okay, of what or for those components. Okay. We'll begin with what? With air. So importance of functions of soil components. Okay, so we'll begin with air. All right, so air. All right, so we know what air is. Air is a mixture of what? Of gases. Okay, so oxygen is used for tissue respiration of the roots. Take note of that. Oxygen is what is useful for tissue respiration of what? Of the root of what? Of organism. Of organism. Air is also very, very useful. Oxygen is used for during what? Germination. Okay, so the importance of what? Of air or oxygen cannot be what? Overemphasized. Okay, so number 1, you say that what? Oxygen is used for tissue respiration of the roots and soil organisms. Okay, and like I said, it's also useful for what? For germination. Okay, so that is what air. Okay, oxygen is useful for tissue respiration of the roots and soil organisms. Also, what? For germination. Then number 2, CO2 also, which is what? Carbon dioxide. CO2 increases what? Soil acidity, hence determining the distribution of soil organisms. All right. So carbon dioxide also increases what? Soil acidity. Okay. Thereby what? Determining what? The distribution of what? Of the organisms. Then number 3, nitrogen also. Nitrogen is useful for making what? Protein. Nitrogen is useful for making what? Proteins. Okay, it's also useful for what? For making amino acids. Okay, which are what? Useful or important to the growth of plants. Which are important to the growth of plants. Okay, so that air. Okay, oxygen is used for tissue respiration of the roots and soil organisms. Also for germination. CO2 increases what acidity. Okay, which determines the distribution of what of soil organisms. Also, nitrogen is useful for making proteins, for also making amino acid, which is what important to the growth of plant. Now, let us quickly see the importance of functions of what of water. All right, let us now talk about the importance of water. Please like this video, subscribe, share. All right, like this video, subscribe, share. All right, you are the one that what make others succeed. Okay, your actions on the video, okay, will make others succeed. All right, and then of course, let us look at what water. Now, for water, it is a medium through which soil nutrients dissolve. Okay, water is a medium, number one. It is a medium through which soil nutrients dissolve. Water is very, very, very important. Okay, it is very, very, very important. Okay, and it's a medium through which what soil nutrients dissolve. Also, water is what is a medium of what of transport in plants. Okay, all right, where they transport what the minerals. Okay, they transport transport what their food also. Okay, so water is what is a medium of what transport in plants. Okay, so I've seen what the xylem, I've seen what the phloem, okay, and what they are able to what to transport or minerals, okay, to what to other part of what of the plant. So water is a medium of transport in plants, and water also is necessary for the germination of seeds. Okay, so without water, seeds may not what germinate. Okay, so it is necessary. Number three, it is necessary for the germination of seeds. I don't know if you are going to plant what a seed during the dry season before when there's no when rain is not falling. Okay, you see what the performance of what of that particular plant you are planting. Okay, it will not do well, definitely. All right, so water is what very, very necessary for the germination of seeds. It is also used in the translocation of plant nutrients. Okay, number four, used in the translocation of plant nutrients. Okay, so water is also very, very, very useful in the translocation of what of plant what nutrients. Water also washes away accumulated salt and other toxic what substances from what from the plant. Okay, so it washes away. Number five, washes away salts, excess salts, and what other toxic substances, toxic. Okay, from what from the plant. So water, without water, water is just very, very necessary. Okay, so these are just few of them. Okay, so water washes away excess salt and other toxic substances. Okay, from what from the plant, and water is also what raw material for photosynthesis. Okay, so these are just what a few of them raw material for photosynthesis. Okay, that's number six now. Okay, so now we're done with water. So let us now talk about what inorganic matter. All right, inorganic matter. All right, so inorganic matter is also important because it forms the framework of the soil. Okay, it forms the framework of the soil. Okay, inorganic matter, it forms the framework of the soil. Okay, so inorganic matter is also very, very important. Okay, because what it forms the framework of the soil, and inorganic matter also provides kind of support, a firm anchorage. Okay, for what for plant roots. Okay, it helps to what to support them. Okay, right. So number two, it provides a firm anchorage for plant roots, okay? A kind of what support, okay? All right. So those are what that's what inorganic matter is. Provides what a very, very, very firm anchorage for what for plant roots. It supports what plant roots. Inorganic matter also provide mineral salts to the what to the plant. Okay. Also provides mineral salts to the plant. Okay, so it helps to us also provide the plant with mineral salts and has pores in between them. Okay, which are what covered by air and water. It has what pores. It has pores. Okay, between them, all right, that are occupied by air and water. So inorganic matter is also very, very, very important. Now let us now talk about what the organic matter. All right, so in terms of the organic matter is the source of food. Okay, source of food for soil organisms, organic matter. The source of food for soil organisms. Very, 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 very important. All right, so let us see organic matter. Okay, we say what? It is a source of food for soil organisms. Okay, so organic matter is a very, very, very good source, okay, of food for what? For soil organisms. And when what organic matter decompose, it's a very good source of what? Of mineral salts. Okay, so it is a good source of what? Of mineral salts when they what? Decompose. All right. So when they decompose, they are a very, very good source of what? Of mineral salts. Please take note of that. Those are what? Organic matter. All right. They are a good source of what? Of mineral salts when they decompose. Organic matter also is spongy. So it allows what? Water to percolate or what? Drain through the soil. It is what? Spongy. Okay, it is spongy and therefore allows for water to percolate, okay, to go through it, all right, or will drain through the soil. So organic matter is what? It is spongy, okay, and what allows what? Water to percolate and drain through the soil. Okay, so the soil needs what? This kind of thing. All right, so it is spongy. It allows for water to percolate it, okay, and what? To drain through the soil. Organic matter also improves what? Soil structure. It improves soil structure. Okay, it's also what? Improve what? Soil or water holding what? Capacity of what? Of the soil. All right, it's what? It improves water holding capacity of what? Of the soil. All right. So it improve what? The soil structure as well as what? Improve what? The water holding capacity of what? Of the soil. Likewise, it insulates the soil against what? Extreme heat and cold. All right. It insulates the soil against extreme heat and cold. Okay, so that is what I think this is enough for the organic matter about what the importance, okay, or what the function. Okay, so please take note of that. It's a source of food for soil organisms, good source of mineral salts when they decompose, spongy and allows water to percolate or drain through the soil, improve the soil structure. It improves water holding capacity of the soil and insulate the soil against extreme heat and what? And cold. Now let us talk about the soil organisms themselves. Okay, now what is that the importance of the soil organisms what themselves? And you know that these soil organisms, they dig what? Tunnels, okay, in the what? In the soil, okay, allowing what? Water, all right, to drain well, all right. So soil organisms likewise, they are also very, very, very important. Okay, so soil organisms, note that what? They increase what we call what? Aeration. and drainage by constructing or by the construction or by constructing tunnels that are filled with air, that are filled with air and water to pass, and okay, that filled with air and allow water rather, and allow water to pass through. All right. So soil organisms what are very important. All right. They increase aeration and drainage by constructing tunnels that are filled with air. Okay, and then they allow water to pass through them. Okay, which helps to help the soil to retain water also. Very, very important group of organisms. Soil organisms, they are as important as anything. Also, they mix topsoil with the subsoil. Number two, they help to mix topsoil with with the soil. All right. So the top, they'll bring the top down. They'll bring the down to the top. Okay. So like for example, termites, e.g., termites. No termites now. Okay, when they are building their nests, all right, they do this. Even earthworms, they do this, all right. So they have to mix the topsoil with the subsoil. Very, very, very important. Likewise, they decompose organic matter, all right. Number three, they decompose organic matter, all right. They decompose organic matter. Very, very important. And then also, they weather rocks, okay, to form soil. Number four, they weather rocks to to form soil. Okay, so biological weathering. All right, so they can burrow into rocks. Okay, and eventually lead to the breakdown of those rocks. So they weather rocks to form soil. They decompose organic matter. All right, they weather rocks to form. Very, very important. But unfortunately, some cause diseases, okay, to plants and animals, okay. But you can't have it all, okay. Some cause diseases to plants and animals, okay. So all of these, all right, are I've seen the importance of all of the components of the soil, all right. The soil organisms, organic matter, inorganic matter, air, water, all right. Please make sure you take note of them. Read them. So for biology, you have to read and read. Okay, form your notes, read them over and over again. That's why the OTV Schools app is very important, because you have your notes already. So you read them over and over again so that they can Then try to build understanding. Don't just cram them. Okay, the reason why I'm able to still remember most of this is because I did not cram them. All right, so I just one major look at them again becomes clearer. So please do not cram anything. Just try to understand them. Like soil organism now, that earthworm. Just look at earthworm, for example. How it digs into the ground. They build tunnels, okay? And that's what they say here. They increase aeration by drainage, by constructing tunnels, all right, that are filled with air, okay? So it's as simple as that. You try to build your imagination when you read, okay, so that the retention will be much, much better. All right, so now let us continue. Let us now go to soil profile because of time. Soil profile. Soil profile. Here we're going to see the different size of the type of soils that we have. All right. So soil profile. Now, what is soil profile? Okay, it's very important. First of all, talk about soil profile before now. Start talking about sizes of particles or how they are classified. Okay, so soil profile is a vertical section. Through the soil, okay? It shows the different layers, showing the different layers from the top, different layers from the top to the parent rock, okay? So that's soil profile. Soil profile is a vertical section through the soil. And what does it show us? It shows us the different layers from the top to the what? To the parent what? Rock. Okay? Please take note of that. It's very, very important. And of course, you should take note that what? The classification of soil is based on what? Two types. Okay? One is what? The size of the particles or texture. Okay? Then the second one is what? Is the soil color. All right? So we classify what soil based on what? On the size of what? Particles or texture, and what? On the soil what color? Based on the soil color, or based on the size of the particles or what? The texture. Now, quickly, we have what? Three types of what? Of soil. Three types of soil based on the size of particles. Okay, so based on the size of particles, we have what? Three types of soil. Number one is sandy soil. Number two is clay. Number three is loamy. All right, please take note of this. All right, so based on what? On the size of particles, we have sandy soil, we have clay soil, and we have what? Loamy soil. Based on the size of what? Of their particles. And then now, the relative sizes of what? Of these soil particles. Relative sizes of what? Of soil particles. That's relative sizes of all the particles that are found in the soil. It is very important that you also take note of that. Now, number one, we have what? On the soil, we have what to call what? The gravels. We have gravels, all right? And these their sizes are in millimeter. Sizes in millimeter, okay? The size of what? Of gravels, okay? So this is a soil particle. Gravel is a soil particle, and its size ranges from 20 to what? To 2 what? Millimeters, okay? For gravels, we have 20, from about 20 to what? To 2 what? Millimeter. This is the size. Now, after gravels, we have what? Coarse sand. These are the biggest, okay? They are the largest. Okay, then after them, we have coarse sand. Coarse sand. This one ranges for what? From 2 millimeter to 0.2 millimeter, okay? From 2 to what? 0.2 millimeter. Then after coarse sand, we now have fine sand. Fine sand. Fine. Fine. Fine sand. This one, they range from what? 0.2 to what? 0.02. All right? Those are what? The fine sand. Okay, after the fine sand, we now have what? The silt. The silt. SILT. Okay, this one, they range from what? 0.02 to 0.002. Okay, then after the silt, we now have what? The clay. All right, and the clay, they are less than what? 0.002. So they are less than 0.002. Take note of that, okay? So say what? Based on size of particles, we have what? Sand, clay, and what? Loamy, all right? Now, the relative size of what? Of particles, okay, on the soil is this. For gravels, from 20 to 2.0. From what? For coarse sand, we have 2 to 0.2. For fine sand, 0.2 to 0.02. For silt, we have 0.02 to 0.002. Then for clay, we have what? Less than 0.002. All right. So now from here, we move on to characteristics and properties of different types of what? Of soil. Characteristics and properties of different types of soil. All right. So let us see characteristics. Okay. Characteristics. All right, of what? Of different types of what? Of soil. And we'll begin to talk with clay soil. Clay soil. Clay soil. Now, for clay soils, okay, one of the characteristics that you observe in clay soils is that they have what? They have, number one, very small particles which are closely packed. They're closely packed together. Okay, so they have what? Very small particles which are closely packed together. Because they are packed together, that means that what? The spaces between them is what? Is very, very limited. Okay, so they have what? Limited air spaces between them. Okay, their particles are very small, and they are closely packed together. Then also, number two, they are poorly drained. Poorly drained, they are waterlogged, and very importantly, they have a very high water retention capacity. They can retain water very well, okay? They have high retention, all right? So that's what clay soil. Number two, poorly drained. They are poorly drained. When water enter, okay, to commot the water they had, okay? So they are waterlogged also, all right? And then they have what high retention, all right? So that number three, they are fertile. They are fertile, and the reason why they're fertile is due to the fact that they can retain what nutrients, okay, all right. So anything that goes in there, they can retain it, all right. So they're fertile due to high nutrient retention capacity, and also they have a low leaching. Okay, their leaching rate is very, very low. All right, so there are clay soils that they are very, very fertile. But one other thing is that they are very difficult to work on. Difficult to work on. All right, so that's what for clay soil. They are very small. They have very small particles which are closely packed together. Hence, they have a limited space between them. They are poorly drained. They are waterlogged, and they have high retention. They are fertile due to high nutrient retention capacity, and they are low leaching. Then also they are difficult to work on. All right, next now look at what silt. 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 All right, so we have what silt. Now for silt, okay, let me just quickly rush through silt. Okay, they have good drainage. Okay, they also retain water also. All right, they also have nutrients. All right, so for silt, number one, they have good drainage. All right, and they are easy to cultivate. They are easy to cultivate. All right. They also have high fertility, very high soil fertility. They have a very high fertility. They are fertile. All right. Then they have a very small quartz particle, mainly silicon dioxide. All right. They have that's number four now. Very small quartz particles, mainly silicon dioxide. All right, so they have very small quartz particles, mainly silicon dioxide. And then likewise, also number five, particles are smooth, SMOOT, and powdery. All right, so silt particles, they are smooth and powdery. And also you should know that they retain water too. So number six, they have high water retention, okay, or high water holding capacity. All right, so that is that word for silt. Good drainage, easy to cultivate, very high fertility, very small particles, okay, mainly silicon dioxide. Particles are smooth and powdery, and they have a very high retention. Now let us now go to sandy soil. All right, to sandy soil. Please make sure you like this video, and take note of all of these. Take note of all of these characteristics. They are very important. Okay, let's talk about sandy soil. Now, for the sandy soil, they have very good drainage, okay? Because once you take sandy soil now, you put water into it, okay? You can easily drain out immediately. It has a very, very poor water holding capacity. In fact, it does not have it is not rich in nutrients because all the salts, okay, all the dissolved salts are washed out, okay? So, but they are easy to work on. On the bright parts, okay, they are easy to work on. So let us quickly see what their characteristics in the nutshell. Number one, they are very good, okay, in terms of drainage, okay. They have they have very good drainage. And the reason why they have very good drainage because of they have spaces, okay. They have large hair spaces between them. All right, so that is due to due to large spaces in between parts Okay, that is number one. They have a very good they have very good drainage due to large spaces in between the particles. Then number two, they have a poor water holding capacity. Poor water holding capacity. But on the bright side, like I said, they are easy to work on. All right. Then number four, since all of the nutrients have been washed away easily, they do not have what they have very good drainage. All right. So because of that, they have what very poor fertility. Right. So poor fertility due to what rapid leaching. All right. So you can say due to rapid leaching of mineral salt. Okay. Then also they are not good for cropping. Number five. Not they don't have they have poor fertility. So how would they be good for cropping? Okay, so they are not what good for what for cropping unless what you fertilize it. Okay, so if you fertilize it, okay, it may help a bit, all right, but they are not good for what for cropping, all right. And then they have what a high rate of leaching, like I've said, and they have good aeration due to what? Due to large air spaces what between them. They have good aeration due to what? Large, so good aeration. And this is due to what? To the large air spaces that are between them. Now let's quickly talk about loamy soil. Okay? Loamy soil. Now for loamy soil, all right, you know that everything good is installed with loamy soil. Everywhere good, easy to work on, okay, all right, has high fertility, all right, and it's the best soil, very arable also, all right. So let's quickly rush through what them loamy soil is the best for planting. So number one, we have what good drainage, AGE. Then number two, they are easy to cultivate. Then also they have what fertile soil. So you say fertile soil with sufficient supply of soil moisture, of air, and plant nutrients. Okay, and number four, they are very arable. All right. So these are what some of what the characteristics of what of loamy soil. They have good drainage. They are easy to cultivate. Fertile. They have a fertile soil with sufficient supply of what of air, soil moisture, and what plant nutrients. Okay, and they are very very arable. Very very arable. Now let us quickly see how to determine the percentage of what of water in soil sample. Okay, the percentage to determine the experiment rather to determine the percentage of water in soil sample. Okay, determination of what? Determination of what? Of percentage of what? Of water in soil sample. Now, if you want to determine the percentage of water in soil sample, it's very, very easy, okay? So you take a dish, all right? Take a dish, you weigh the dish, all right? Then you add what? Wet soil, okay? And into the what dish. Then you also weigh it. Okay, now after you have weighed it, then you now carry what? The dish, and then what? The dish now plus the what? Wet soil, okay? And then what? Heat it, all right? To what? To 100 degrees Celsius while you are stirring it. All right. Then at this point, each of them, when you weigh the dish alone, you record the weight. Okay. When you weigh what the dish plus what the wet soil, you record the weight. When you weigh, then when you put the dish plus the wet soil in what in heat and start stirring and heating it to 100 degrees Celsius. After the soil is now what the water has escaped from the wet soil. All right. Then you also record that weight. Then you repeat this process, okay, until you get a constant weight. Okay, so that's basically how you determine the percentage of water in the soil sample. And when you are doing this, these are some of the what parameters that you see. So number one, you are going to have what the mass, okay, or the weight, because I'm going to weigh what the empty dish. So I'm going to have what the weight of what of the empty dish. All right. So number one, you have mass of empty dish. Okay, let us say the mass of empty dish is what? Is a gram. Okay, it's in what? It's in gram. All right. Then we now have what mass of what of the empty dish plus what plus the wet soil, isn't it? They are now going to have what mass of wet soil then plus what plus dish. Okay, let us say this mass is b gram. All right. Now, after having the mass of wet soil plus the dish, and I'm going to have mass of dish plus dry soil now. Mass of dish plus the dry soil. This time, let's call it what? CGM, okay? Which is what? C gram. This is B gram, A gram. Now, this is what? Mass of empty dish, mass of wet soil plus dish. Then mass of the dish plus dry soil. That means that what? You have be able to successfully heat the water away from what? From the soil was sampled. So it's just what? A dry soil now. Then up next, I'm now going to have what? Mass of water in the soil sample. Mass of water in the soil sample. Okay. So now what will now be the mass of water in the soil sample? From where did the water vanish from? Okay. It was when you heated this mass of wet soil plus the dish. Okay, that water evaporated. Okay. So here now mass of what? Dish plus dry soil. So if you want to have the mass of the water in the soil sample originally, then you need to what? Subtract what? C from what? From B. Okay. Subtract C gram from what? B gram. So I'm going to have what now? B minus what? C. Okay. Also in what? In gram. All together. All right. So let me go over that again. If we are looking for the mass of water, all right, in the soil sample, you subtract what? The mass of dish plus dry soil from the mass of wet soil plus dish, because this B will be bigger than what? This C, isn't it? So that you have what? A positive value there. All right. So it's as simple as ABC. Now, up next, after looking for what? Mass of water in the soil sample, all right, I also look for what? Mass of soil plus water. Mass of soil then plus water. Now, how do I get mass of soil plus water? Now, where's the mass of what? Of soil. All right. Mass of soil plus what? Plus the water. Okay. So this is what? Mass of wet soil. Okay. We have mass of wet soil here plus dish. Okay. So that means this soil has what? The water, isn't it? So now that means if we remove what? If mass of wet soil plus dish is BGM. Okay. Then if we're looking for what? Mass of wet soil, because that's basically what we're looking for here. The mass of the soil that has the water in it is what we're looking for, is the mass of the wet soil. So if we're looking for mass of wet soil, all we need to do is what? To subtract what? B from what? From A, because the mass of empty dish is A. The mass of what? Wet soil is what we're looking for. We know what the mass of dish. So I also know what? That this mass of wet soil plus dish is B. Okay, so to now get the mass of what? Of only the wet soil, we subtract what? A from what? From B. So I'm going to have what now? B minus what? A. This is going in what? In gram. Now, we'll now determine the percentage of water in the soil sample now. Okay, that will now be what? The percentage of what? Will now be what? The ratio of what? Mass of what? Of soil plus water all over what? Now mass of water in the what? In the soil was sample. Okay, so now that means we're going to have what now? B minus C over what? B minus A times 100%. The ratio of what? Of mass of soil plus water and what? Mass of what? Water in the soil sample. Okay, since the mass of water in the soil sample is what? Is B minus C, the mass. Okay, then the mass of soil plus water is B minus A. Then this will be what? The percentage or ratio. Okay, to be B minus C over B minus A times 100%. Okay, let me go over it one more time. So we have mass of empty dish to be A, mass of wet soil plus dish to be B. Okay, mass of dish plus dry soil. We have heated this now. Okay, water has left. We now got C. So if we want to get mass of water in the soil sample, all we need to do is what? To subtract what? This mass of wet soil plus dish. Okay, from what? Mass of what? Dish plus dry soil. all right, to now get what that difference. That will now give us our GM. Now, B minus C gram. Now, mass of soil plus water is mass of wet soil, okay? The soil that has what the water. So from here, since we know the mass of the dish to be A, okay, just to say mass of wet soil plus A is equal to B. Okay, so to get mass of wet soil will be what? B minus A. Now, to now get the percentage of water in that soil sample will be what? The mass of what? Of the water itself. Okay, which of the mass of the water in the soil sample, which is this B minus C, then all over what? Now, mass of soil plus water. Okay, which is what? B minus A times what? 100%. We'll see calculation. So, okay, so we use it in calculation. And by the time we start talking about past question now, you see what all of this calculation and how useful they are. Now, let's quickly look at soil fertility, all right? Soil fertility. Please ensure you like, subscribe, and share this video to your friends and loved ones. What is soil fertility? Definitely will not be more than what? How fertile, okay? All right? Soil what is? Soil fertility. So, soil fertility. Now, what is soil fertility? Soil fertility is the ability of the soil to supply plants with what? With nutrients, so as to what? To be able to sustain their growth. Okay? That's all what soil fertility talks what about, and what we're going to look at what how it can sustain it and how soil fertility can be lost. You must take note of them. Okay, they are repeated exam questions. Okay, you do not joke with those kind of questions. So, say soil fertility is what? The ability of the soil, SOIL, to supply plants with nutrients in appropriate quantities. In appropriate quantities in order to sustain their growth. Okay, so that's what we know and call as what? As soil fertility. The ability of soil to supply plants with nutrients in appropriate quantities in order to sustain their growth. All right, so how can we sustain soil fertility? Okay, by manuring, okay, by what's it called? Crop rotation. Okay, these are practices that can what? Help us to what? To what's it called? To sustain soil fertility. So among them, we have what's your crop rotation. All right, we have what? Manuring. We have what? You can apart from manuring, you can add fertilizer. Addition of fertilizer. All right, we have following, and also reducing soil erosion. Okay, soil erosion. Okay, so these are ways that we can use to sustain what? Soil fertility. Okay, crop rotation is very, very important. All right, then number 2, manuring, then add fertilizer, then following, and what? Reducing what? Soil erosion. Okay, but easy ways for us to lose soil fertility is 1, through soil erosion. Okay, just allow erosion to pack everything up. So let's talk about loss of fertility, loss of soil fertility. Number 1, crop rotation is for sustenance. Okay, while what? Monocropping, okay, is what? It can lead to what? Loss of what? Of what's it called? Of soil fertility. Then continuous plowing or cultivation. Continuous plowing or cultivation, okay, can also lead to what? To loss of soil fertility. Then number 3, soil erosion, then even leaching, then crop removal from soil. All right, all of this can lead to what? Loss of soil fertility. Please take note of what? Of all of these. They are very, very important. Okay, so loss of soil fertility, monocropping, continuous plowing or cultivation, soil erosion, leaching. Okay, they are all what? Ways that what? The soil can lose is what? Fertility. Now we move to conservation of natural resources. Conservation of natural resources. We have natural resources and they need to be conserved. Okay? They need to be what? Conserved. All right, they need to be what? Kept for the use of what? Of mankind. Okay, so that's what conservation of what? Natural resources. Say conservation of natural resources. Conservation of natural resources. Okay, it involves what? Safekeeping of natural resources. Safekeeping of what? Natural resources for the use of mankind. All right, for the use of mankind. Some of you will be pumping water in your house. Okay, 1 hour, 2 hours, you refuse to off it. Okay, that is not, you are not conserving your natural water. Is a natural resource. Okay, so you have to what? Conserve them. Wildlife, they are natural resource. All right, so conservation of natural resources entails what? The safekeeping of what? Natural resources for the use of mankind. And say examples of what? Natural resources include like soil, like your water, like your wildlife. Okay, your forest, your minerals. All right, your sunlight, your air, all of these are what? They are natural what? Resources. Okay, so conservation of natural resources is what? Safekeeping all of these our natural resources. All right, for the better use of what? Of mankind. All right, so we can classify what? Natural resources into two. We have a renewable and what? Non-renewable. Okay, renewable or natural resources are those resources that can be replaced, okay, after what? Being used. Okay, so after you use them, you can what? You can replace them. All right, examples are what? Are animals. Okay, then what? Trees. Okay, we can replace them after what? Using them. All right, those are what? Renewable what? Natural resources. Why what? You have the non-renewable. This one, they cannot be what? Replaced after use. Okay, once you have used them, you have used them. Okay, for example, we have petroleum, okay, gold, and what? And the rest, etc. So all of these are what? They are non-renewable what? Natural what? Resources. Okay, please take note of all of that. Now let us now quickly talk about what? Conservation of soil. Conservation of soil is just the safekeeping of what? Of our soil. So we have to what? Avoid some what? Some what's it called? Some practices so as to keep our soil what? Safe. Okay, to avoid what? Some practices so as what? To keep our soil safe. So what are some of those practices? We're looking at conservation. So what are some of those practices? Number one, controlling erosion is very paramount. Okay, so if erosion is disturbing, okay, our what? Our soil, it will keep washing away what? The nutrients. Okay, it will keep washing away the nutrient, and it is not good. Okay, it is not good. All right, so we are not conserving it by allowing erosion to be washing away the nutrients. All right, so we control what? Erosion. Then number two, we have what? By adding what? By improving soil fertility by adding manure. Improving soil fertility. Okay, by what? By the addition. Okay, by the addition of manure. All right. Then of course there are some practices to what? Avoid completely, like overgrazing, like over cultivation. All right, all of those habits, all of those practices, we should what? We should avoid them. So number three, okay, overgrazing, over cultivation, overcropping, all of these what? Practices should be what? Completely what? Put away. Okay, completely what? Put away with. All right, we're not supposed to be practicing all of this what? Rubbish. Okay, so then also indiscriminate felling of trees. Okay, indiscriminate felling of trees. Okay, it's also what a bad word practice. All right, please, we need to what ensure that we completely do away with what with it. So that's what conservation of soil, controlling erosion, improving soil fertility by the addition of manure, overgrazing, overcultivation, overcropping should be avoided completely. Then what indiscriminate felling of trees. Also, soil pollution should be avoided. Like for example, oil spillage. Okay, so soil pollution, let's add that. Soil pollution should be avoided. All right, so how to avoid what soil what pollution through what oil spillage. Okay, it is completely very very bad. All right, because when you go to what plants in those kind of what soils are what oil spillage has affected, you know you can never get good yield. All right, so we must avoid what soil pollution. Okay, for what for us to be able to conserve our soil. Also, cover crops should be planted. All right, to prevent what erosion. Cover crops, call them cover crops. Okay, they should be planted like all those our leguminous what crops. Okay, like centrosema, like mucuna. Okay, all of these ones should be planted. Okay, that cover what crops. Okay, to avoid what erosion. Right, cover crops should be planted to avoid erosion. What are the benefits of soil conservation? Okay, it ensures what the preservation of what soil nutrients. Okay, ensures benefits, ensures preservation of soil nutrients. Okay, so that's one benefit of what of soil conservation. We'll conserve our soil, all right, and of course our natural resource, which is soil, for example, what ensure what the preservation of soil nutrients. It also provides healthy habitat for soil organisms. Provides healthy habitats for soil organisms. Okay, so conservation of soil, okay, also provides what healthy habitats for what for soil what organisms, and also is what prevent desertification and soil erosion. Okay, also what prevents desertification and soil erosion. Okay, so these are all what benefits of what conserving what the soil, ensure preservation of soil nutrients, provides healthy habitat for what for soil organisms, and prevent desertification and soil what erosion. Now let's quickly talk about conservation of water. Conservation of water. All right, we're getting close to the end. Please ensure you like this video, ensure you subscribe to this channel. All right, ensure you share the link of this video to your friends, to your loved ones, to your junior ones who are preparing for what for exams. All right, if you have junior ones in SS1, also share it to them because it will be useful to them. All right, before they get to SS3, they're going to book pass you. All right, so how about conservation of water? Now, how do you what conserve what water? Okay, conservation of water. All right. Like I was using an example earlier where we see many people pumping water. All right, they'll pump for 3 hours. Tank don't full since the no gree off farm. Nobody will send. Okay, all these things, those are wrong practices. Okay, so water also needs to be conserved. All right, how do we conserve water? Number one, used water should be recycled afterwards treatment. Used water should be recycled after treatment. It is very, very important. All right. And also, water should be stored in tanks or reservoirs. Right. Number two, water should be stored in tanks or or reservoirs. reservoirs. Okay, and also if you notice that what a pipe is leaking in your house, okay, or the water bowl pipe is leaking or anything, you see, observe any leakage, even in your kitchen, anywhere, ensure they are fixed. Okay, those are the ways that what can help to conserve water. All right. Then also let us talk about conservation of wildlife. Conservation of wildlife. Okay, so for some of you, especially the boys, because I know say girl, they hard girl to go catch rabbit. Especially for the boys, okay. Now don't kill all the rabbit we do in our community. Finish rabbit because of now rabbit no day again. Okay, now they take eye see rabbit. Oh, now go pursue and I will kill her. Okay, please, indiscriminate killing of wildlife should be avoided, should be discouraged. All right, so that's one. All right, so number one, indiscriminate killing of wildlife should be discouraged. Okay, and also the habitat of all this wildlife should be preserved. Okay, all right. You can use it. You can build natural parks for them. Okay, you can build them as sanctuaries for them. All right. So that's why if you go to some countries, all right, you see some go to their parks, you see natural wildlife. All right. Where you can see natural parks, just go there, see different type of animal that you have not seen before. All right, so you can do something like that instead of you killing them. Okay, so we should protect their habitat also. We should conserve them. So we say number two is what their habitat should be conserved or what protected. Okay, by what? Turning them to what? To natural, by building natural parks or game reserves or what? Wildlife sanctuaries. Okay, so we can do all of these. All right, so protect what the habitat where they live. Okay, so you can build natural parks, game reserves, wildlife sanctuaries, and the likes. Okay, so I've taken a lot of time. Okay, so also we were talking about pollution, but in chemistry I've talked about pollution, water, air, all of them. So go to chemistry what's it called, playlist, and go and watch everything that has to do with that. So let's all go to questions now. So we're supposed to talk about do calculation about percentage of humus in the soil, but it's very, very easy. Okay, so please, I'll give you an assignment. Go and learn it. Okay, we'll talk about determination of water in soil sample. Okay, so if you see a question on it, we may solve it. Now, 2015 number 30 says the increasing order of the particle size in the following soil types is silt, sand, clay, gravel. So you tell me the answer in the comment section. This one is easy. B say clay, silt, sand, gravel. C say silt, clay, sand, gravel. D say clay, sand, silt, gravel. Now, 2022 number 17 says, which of these is not a type of soil? A say granite, B say sand, C say loam, D say clay. Then 2022 number 5, it says, which of the following is not a method of conserving soil? A say prevention of overgrazing, which may cause soil erosion. B say prevention of indiscriminate felling of trees. C say pollution of the soil. D say prevention of what? Of bush burning. Okay, so tell me the correct answer in the comment section. 2020 number 25 says water rises most rapidly in A say sandy soil, B say clayey soil, C say sandy loam soil, D say loamy soil. Okay, water rises most rapidly. Okay, tell me the correct answer in the comment section. Okay, now we have a question here that has to do with percentage of water in the soil. So 2015 number 21. Okay, so we'll solve this one and then you go and solve the rest. All right. Okay, let's solve this one. You go and solve the rest. 2015 number 21. It said a crucible of mass 5 gram, okay, weigh 10 gram after being filled with what? With fresh soil. Mass of crucible alone to be what? 5 grams. You can see the question, right? Then they say we're now giving what? Mass of crucible, then plus what now? Fresh soil to be what? 10 grams. Okay? Then we're now giving what? Mass of crucible plus dry soil. That's after heating. Give us 8 grams. Okay? So what do we need first of all? All right. So for the question we're asking for, they are asking for the weight, the percentage of what of water in the soil. Okay. Now, weight of what? The fresh soil alone. Okay. Weight of fresh soil alone. Since you know weight of mass of crucible to be 5 grams, mass of crucible plus fresh soil is 10 grams. Mass of fresh soil alone will be what? Will be what? This 10 minus what? 5. 10 minus what? 5. Okay, in gram, which is what? 5 grams. Okay, so I've now found what the mass. Okay, the mass of what? Of the soil. Now, dehydration has happened. Okay, they have removed what? The water from what? From the from what now? From the fresh soil. Okay, leaving us for dry soil. All right. So now, if we want to now calculate the mass of what water that was what dehydrated, it will be from this mass of crucible plus fresh water and this mass of crucible plus dry soil. Okay, because it was lost from this process. Okay, during what? What's it called? During dehydration. So now, mass of water will be what now? I'm going to have what now? 10 grams or 10 minus 8. Okay, in gram, which is what now? 2 grams. Now, to calculate the percentage of water, okay, in what? In the sample would be what? This mass of water over what now? The mass of what? Of fresh soil, then times 100%. So I'm going to have 2 over 5 times 100%. 5 here, 1, 5 here is 20. 2 times 20 is 40%. This question should not take you 1 minute. All right, so that is the answer. 2015, number 21. So let us go to, now you will do 2009, number 6. Tell me the answer in the comment section. You do 2007, number 6 also. You do 2016, number 10. You tell me the answer in the comment section. 2014, number 35. You tell me the answer in the comment section. All right, you do 2008, number 37. You tell me the answer in the comment section. All right, then do we have any other one? All right, 2024, number 39. Tell me the answer in the comment section. All right, so that is that for that. Please ensure you do all of them so that you can gain understanding. Okay, use this as what? As a, then use the, when we did determination of what water in soil sample. Okay, we did the, we try to what? Explain the experiment and then I give you the parameters. Go back again, look at it, and then look at this example. Then do what? All of this, okay? Answer the question, tell me the answer. Then just tell me the options, okay? In the comment section. All right? I wish you all the best. Thank you for watching. I'll see you in the next episode.